Greetings, scholars, and welcome to this video on finding points on a curve with a given slope. This is in a series of videos about slope in my pre-calculus class, probably useful for some intro calculus early on. And if I'm saying something about slope here on a curve, we're hoping we're thinking by now we're going to use the derivative, okay? I'm going to do this very mechanically with a set of steps. And these steps are, in fact, 1, find the derivative. To do this, at an elementary level in our class, we've just been using the power rule. Later in calculus, there are many methods for finding the derivative. Okay? And then step 2 is set the derivative equal to the given slope. Okay? Step 3 is solve for the x's potentially. You might be finding more than one point, depending on the nature of the curve. And step 4 is use the original function to find y. And I guess I should throw in here, it might be more than one y if you've found, in fact, more than one x. Okay, so let's get going here. And we're going to ask this question. At what point or points on the following curve is the slope equal to 1? And the curve is f at x equals negative 1/2 x squared plus 3x plus 6. I have a graph of it right here. Just to conceptualize this problem as an idea, I've taken this line here, and it has a slope of negative 1. I measured it earlier against this piece of little graph paper here. So the question is where would I make a tangent line on this curve so that the slope has negative 1, just kissing it. It looks like it's going to be right about there, I guess. I'm just estimating, okay? So we should be finding something of that nature when we do the problem. Some point in this neighborhood on the graph, if you will. Okay? Give or take, because I am eyeballing it, but I'm just trying to give you an idea how the problem works. So, just working the steps now, we are going to take a look here, and I'm going to find the derivative. I'll do that in red. So I will do my notation of f prime, and my power rule, negative 1/2 times 2 is negative 1, writing the base, decreasing the exponent by 1, so I don't actually need to write to the first power. Okay, then for the next term, I will in fact be doing 3 times 1 is 3, and then writing the base is unnecessary because I'm decreasing the exponent by 1 and getting an exponent of 0. Okay, so my derivative is just quite simply f prime at x equals negative x plus 3. And don't forget, the derivative is equal to the slope. Okay, this is a slope finding function. So this says slope and that says slope. And we notice here up in the problem it says that the slope is negative 1. So, quite frankly, this guy right here, the slope is equal to negative 1. If you notice in step 2 it says set the derivative equal to the given slope. So here's my derivative, negative x plus 3, and it is in fact equal to negative 1. Again, I've just written slope equals slope. This equation makes sense. The slope function is equal to the given slope. Can't reiterate that enough. Okay? So then we're going to solve for our x's. In this case, you can probably see it's just 1x because it's a linear derivative. So I'll subtract 3 and get negative x equals negative 4, and this gives me x equals 4. Okay? Now, it says point. Now, point, if you notice, is an x comma y. I only have an x value here. Okay? So it would make sense for me to, in purple here, I'll use the original function to find the y's. Okay? In this case, it'll just be 1y. So I'm going to do f at 4, which is going to give me negative 1/2 times 4 squared plus 3 times 4 plus 6. Okay, now depending on who your teacher is, the amount of work you need to show might vary, but for me, the one thing I'm letting kids do in my class is getting this just set up to show that you're evaluating a function, and then go to your calculator. Well, if you notice, I have the function here, so I can just hit the trace button, type my 4, and hit enter, and in fact, I'm getting an output of 10. So, if you notice here, I'm getting this function is going to have an output of 10. So that makes my point, which is my final answer, to be 4, 10. Now this should make sense here in this picture, like I said, because this point here is about 4 comma 10. If you counted the grids, you don't need to. You saw it on my calculator here. It matches. And what you're saying there is that slope of -1 that has that tangent line that I drew, it actually seems like it fits on that graph quite nicely. Okay, so let's do a little harder example. If you notice here, we found 1 point. In the next example, we'll find 2. I'll tell you flat out that's going to happen because the level of difficulty is going to go up. Okay? Okay, so let's take a look at this example. At what points on the following curve is the slope equal to 2? Okay, that curve is not right. Oh, just needed to make a quick adjustment to the function. I had the wrong example up here. So here we say at what points on the following curve is the slope equal to 2? And we have x cubed minus x squared minus 5x plus 6 is the curve. And I just kind of prefabbed up these lines, these little tangent line tools that we're going to use here for a second. And these have a slope of 2. So where is that actually going to fit the graph nicely? Well, if you notice, I guess it looks like here would be kind of a tangent line, which is close to the relative max. And I guess here, close to the relative min, because the steepness of the graph is so sharp that it goes from a slope of 0 to a slope of 2 pretty quickly. Okay, so it's going to be kind of in those areas I should be trying to pay attention to. Okay, so let's do this in color-coded again. I'll find the derivative with the power rule. I'll do that in red. So my f prime at x, by doing the power rule, is 1 times 3 x to the second, -1 times 2, x to the first, minus 5 x to the 0, which I don't have to write, and then the derivative of any constant just becomes 0, so the derivative of 6 is 0, again, because it's 6x to the 0, so 0 times 6 would cancel. Okay, so now that I have the derivative, step 2 is set the derivative equal to the given slope. Okay, so setting the derivative equal to the given slope, okay, would be a slope of 2, given slope. And it's equal to the derivative because the derivative is the tool that finds the slope. So the output of the derivative function is 2 because it generates a slope of 2, and I'm trying to find the point, so it makes sense to find the x to start. Okay, so from here, I'll subtract 2 because I see it's a quadratic, and I'll get 0 equals 3x squared minus 2x minus 7. Okay? So continuing on to the next step where it says solve for the x is, which makes sense because I should be getting 2 of them here because it's a quadratic. I'll just quickly do the quadratic formula. Now again, follow the directions on any test or quiz. Your teacher might allow you to use your root finding function or a program to solve this. So just pay attention to what's asked of you. Okay? So a is 3, b is -2, and c equals -7. So using the quadratic formula, we get x equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So continuing on, we're going to get x equals 2 plus or minus the square root of 88, just using your calculator, over 6. Now from here, because I'm going to get a decimal, okay, I'm not going to simplify this radical because I know I'm going to try and get a decimal here because I'm trying to approximate an actual place on a graph. So, and then using your calculator to get that decimal, we're going to get x is about -1.23 and 1.90, about. Okay, I could have gotten exact values there, but I prefer to get these estimated values so you can actually find the point on the curve. Okay? So now we are going to use the original function to find the y's. Okay? So what am I going to do? I'm actually going to do f at -1.23, which is going to give me -1.23 cubed minus -1.23 squared minus 5 times -1.23 plus 6. Now to find that on my calculator, if I already have the graph, I can just hit trace, negative 1.23. And you'll see that it is in fact blinking where I said earlier with my red tangent line at equals 8.78, we'll call it. Okay, so that first point is going to be negative 1.23, comma, 8.78. And at that point, the tangent line has a slope of 2. Okay, now I've got one more point I need to find, though. So I will continue with that. And that means I need to compute f at 1.90. So that's going to give me 1.90 cubed minus 1.90 squared minus 5 times 1.90 plus 6. And again, pay attention to how much work your teacher wants you to show. But I'm actually just going to plug that in now that I've set it up by hitting my trace button, hitting 1.90. And you see that that's blinking at 1.9, comma, negative 0.25. Making my other point 1.9, comma, negative 0.25. So, although these are approximates, they're very close, and just to sort of marry it up to the whole picture, okay, we've got that this point here, negative 1.238.78, is this point of intersection, where the tangent line has a slope of 2, and this point is about here, okay? So the steps here are very important for you to know. You're going to find the derivative, set the derivative equal to the given slope, because don't forget, derivative is the slope. So if I give you the slope, I'm telling you what the derivative is equal to. Solve for the x or x's, depending on how many that you find. Then use the original function to find the y's. This is also a very important skill for if you're finding relative max and min, because although they don't say a number, when we say relative max or min, we are telling you the slope. It's just that that slope is 0 there. So you have to be able to incorporate these skills when doing that, plus a little bit of vocabulary and understanding of the tangent line having a slope of 0 at a relative max or min.